Well, let's continue with this radio. I think at this point we should feed a few signals into it, because I've proven the tubes are good and it sounds like it's near but not quite there yet. So let's do that. I'll turn on my signal generator and I was going to get some material information on this radio, and I haven't. So I don't have a schematic yet to look at. But we can go ahead and try this simple test here. I better turn on the radio. I'm not going to get too far without it being on. Everything look good? Good and safe? Yep. Okay. So first, let's get this on the AM band without any doubt. Push button, AM. Okay, we're on the AM band. Right at one of those spots where there's some oscillation. We'll put it on the lower end of the band. This is around 9, 8, 9. I'd expect it around there somewhere. Signal generator is on. Okay, I'm feeding the signal generator output right into the antenna terminals of this radio, so it's a pretty strong signal. See what we hear. I'm adjusting the output. That's 12, going back down. 9, 8, 7. Well, I didn't hear a thing now. Do we have the volume turned up? Yeah. Nothing at all. Let's put the radio on full supply voltage. 123. Pretty consistent at 123. I'm tuning very carefully now, listening for any response in the radio at all. Oh, what am I doing? We're on the AM band. What am I doing up on 9 megahertz? Duh. Let's see if I get my head working here. Okay, let's turn it down a little bit. Around 900. Nothing. Okay, let's just pump in the IF frequency. You know, I don't know what it is. Did I read somewhere it's 175 kilohertz in this radio? So we'll go way down there. Huh. 175. What was that? Did you hear that? It's like it's trying to break through. Oh ho 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 ho. Okay, that's a hint. You gotta figure out what it is that makes this thing so crackly. Because the what is it? Is it what I'm sitting on top of? 4 dB it is. What's under there? There's nothing under there. Is it? Oh, look at that. I think it's these loose cans here. Boy, everything is sensitive here too. These are the most sensitive though. Okay, got some more noises to get rid of, but that shouldn't stop it from operating. Somewhere in there I heard a tone. I thought I heard a tone. I'm sure I did. And I'm not sure what frequency we're on. My counter's not... my signal generator's signal output's low at this frequency and the counter's not able to count it. But on the dial, 175 is somewhere in here. No. 175 is right around here. 175. The IF might be 455 also. I don't know where I've got this other number in my head. Let's try 455 here. I hear nothing at 455. Pumped into the antenna, that is. And nothing at 175. Well, let's stop the test. I think I've got some more crackly stuff to deal with. A little obvious, isn't it? Surprisingly noisy. I'm going to take this piece right off the radio here. And these cans. Guess I'll have to look underneath and see what's holding those cans on. And this guy seemed to be awfully noisy too, even though it's very rigid, so I don't understand. It's just maybe something is so sensitive that any transferred vibration through the radio makes a noise. Makes it very confusing when you try to isolate the cause of things. Well, hey, I'm still having trouble with my computer, doggone it. Thought I'd solved it with fixing the heatsink on the processor, but yesterday it ran just fine. Not yesterday, day before. I shot quite a few videos in here, no problem at all. And then I wanted to browse the internet. I left the camera software running. I brought up Chrome, which is my browser, and my computer lasted 5 minutes before it just pinged out. This is like the third time now where I've had both the camera software and the browser running at the same time and the computer has crashed. I don't get it. I've taken the video card out of it, just running on the onboard video. I better stick with these old radios because not having much luck with the computer. Now on the other hand, let me tell you this before I get working on the radio again. I didn't get any radio work done yesterday because I spent almost the whole day fixing my furnace, and in the end I was successful, although it was pretty late at night. I spent far too much time trying to find the motor capacitor on my blower motor. There is no capacitor on the blower motor in this old furnace behind me. My furnace is from the 60s, believe it or not. And the motor has no starting capacitor. But I got pretty convinced by looking on the internet that there must be one. So lots of time wasted looking for that. Finally I got a hold of a friend who fixes air conditioning, furnaces, stuff like that as a profession. And he told me on the old motors like that, no. And then he gave me a great hint, just go to Canadian Tire. That's a hardware store here in Canada. A well-known hardware store in Canada. Buy a motor. So I did. Bought a new blower motor, stuck it in there. It's a little like working on these radios. I had one thing after another I had to figure out and overcome. But lo and behold, around 11 o'clock last night, the furnace was fixed. So that was my day yesterday. Didn't shoot any videos. You know, if I'd known what was going to happen, I might have, because it turned out to be quite a journey through all kinds of challenges. But nah, let's stick to doing radios here. So, and the weather's getting cooler here near Toronto. So I got my furnace fixed just in time, I think. Now, how are these IF cans attached here? I see some screws. I see the whole unit is moving in here. Let's try this one up here. Same thing up here. Oh, I can see the screws moving. Okay, so we'll just tighten those things down. Might be easier said than done. Yeah, that's not the right size. You know what drives me nuts? The mix-up between metric and the old British system. And I don't understand why here we are still fiddling around with the British system. Even the British don't fiddle with the British system anymore. So I don't know how many people know the story, but back in the 60s, the United States and Canada agreed to go together forward and switch to the metric system, which is the international system. And Canada proceeded, and the United States balked after a couple of years. The politics was too vicious. And they couldn't make the change. And that's why here we are, and this time Canada is a metric country, but must also... Oh, I'm just ruining insulation here as I do this. I can hear it. Not getting a grip on that one at all. Easier said than done once again. I'm just going to have to force it in there. And whatever happens, happens here. I can't... this big capacitor is blocking my tool here. Phooey, I can't get either one of those. That's not a good thing. I only got one nut of 4 tightened here. And that might be enough to silence this can, but I gotta do something about this other one here. How can I get in there? wire right in the way. Ah! Phooey. I don't want to leave those things so noisy. See if we can't crank down the screws that are on the main transformer here. Oh, that's plenty tight. Sometimes I like to just turn these things, even the most smallest amount will kind of break any corrosion or something else that might be interfering with the contact. Those are quite tight. They've got locking nuts on them. I don't think there's any problem with this being grounded properly. It's all coming back to these cans. And I just I can't imagine I can get some other kind of tool on it there. I'm probably going to eventually change a lot of these capacitors out anyway. They've already smashed up the insulation on this wire here. And anyways, that shouldn't stop the radio from operating, so we know we got more problems. Now where's that capacitor that was cracked? I think it was this one, wasn't it? I think we got to do more localization of where the problem is too, because I'm all over the map still. I know, I'm pretty sure. I think it's quite clear the audio section is working fine. The output of the detector seems to be stuck high, and I'm seeing that in the eye, which is always closed, the magic eye on the front. So why don't we figure out where the detector is? Or we just do some tube voltages around here, and see where we end up. That might be that's an easy thing to do too. And I know I can safely operate the radio even though it's not in working condition. Nothing bad seems to be happening, so we can operate away and test away. Why don't we do that? So now I don't have the push button system in place. I'm going to leave it off completely. At this point I'm thinking that silences the radio. It interrupts either the audio signal going into the audio amp or something worse. So we may not hear a thing while I'm doing this, but that's fine. These voltages should be the same. Okay, just checking everything for safety here. Let's turn it on. See if I can get my voltmeter where you can watch this action here. The action, yes, action. We'll put it on 1000 DC because we're going hunting. Get out my tube manual, I'm going to need it. There's a ticking sound coming out of the radio. No, it's coming out of the speaker. Oh, that's because I've got that piece unplugged. Last time I had the push button piece unplugged, the radio did this clicking thing. Well, I'm going to assume it's not damaging to the radio at all. Just leave it like that, let it click. First thing would be, let's check B+. We'll find the B+ on the rectifier tube, which is this one here. So 263. Okay, 263. The chassis looks like it's 11 volts below something. I don't know if that's an important measurement or not. Okay, so that's our high voltage is 265. So now we'll go to the output tube, which we believe is we're listening to. So it should plus 13 volts. It's a little strange. Whoa! See that capacitor there? One side, 200 volts with a scream when I put this on. I don't know if you can hear it or not, but this very high frequency tone. I'm guessing that was 17, 18 kilohertz there. If I go on the other side of the same capacitor, I get 13 volts positive. That's not good at all. Not good at all. Wait 1 minute. What is going on here? Okay, so here's a capacitor, electrolytic capacitor. 268, 205, 12. Okay, 12. Well, there's a big resistor there. So I'm guessing that's the cathode, and that's the cathode resistor. And this is the cathode no. The cathode bypass capacitor is this guy here. What's this little one for? Well, it doesn't go to ground, does it? It goes to an available pin, and then makes that squeaky connection. Looks like it's heading up for the speaker. So that could be the inductor, in fact, the field coil in the speaker. No, that doesn't make sense. No, this is the output tube. So I should be going to the output transformer, I guess. We should change that guy out, just to be sure you're not leaking positive voltage. But I don't think that's the case. I think what's really going on is I'm reading to the chassis, and the cathode is positive to the chassis by 12 volts, which would make the grid, if we can find the grid here, that might be the grid there. Whoop, plus 7. No, that's not good. Yeah, I think all these capacitors are shot. 10 on one side. Yeah, look at this. I got 82 volts there. That's not very good either. Nothing there. Nothing there. Funny sounds there. Here, I think you can get a closer view of what I'm doing here. Just do this. tall radio. The camera lens has some interesting effects. Now you can't see the voltmeter anymore, but that doesn't matter. So here's what I'm doing, because listening to it's pretty good too. Touching right there, and that's one of the IF coils. There's high voltage on that IF coil. There's high voltage on that IF coil, one lead anyway. So coming back to this tube here, so there's the screamer, 200 volts, that's ground, that's ground. There's what I suspect is the cathode that I haven't looked yet. That I think may be a heater. That I think is the grid. So if that's the grid and this is the cathode, minus 4, that's just nice. That's nice. It's very nice. I like the grid to be just a little bit negative normally. That's a high voltage there. Output tube seems okay. But we should probably consider replacing these capacitors. I mean, look at them. They're not looking too good. Although looks can certainly be deceiving on a capacitor. Okay, so the high voltage around the output tube seems fine, and you know what? That's not too surprising because I think the audio is working okay. We should really work our way towards the detector tube. The detector. The 6SA7 I think is a detector. 6, let's check in the book here. 6SA7, used as converters in superhet sets, similar to a 6BE6. Pentagrid, frequency conversion, 6SA7, very good. So wherever the 6SA7 is, I can't remember exactly, that's the detector. We should go poke around with that. Let me just look at the tube chart over here. Okay, wait 1 second. I have a photograph of the tube chart. Let's take a look at that. I took a photograph with my tablet computer. Which I'm looking at right now, and the 6SA7 is middle of the back. Okay. So the 6SA7 is this tube here. This one in behind this capacitor. So let's poke around with that guy a little bit. I can't see the readings. My own hand's in the way there. A little noise. There's 100 volts there. We got a minus there. Nothing there. A little hard to get in here. Zero there. Looking for a pretty strong shot of high voltage here. Zero there. There's the high voltage, 200. 100 again, the first pin. So 200, 100, all the rest are low. You know, that's pretty normal for a tube. So we'll work our way up the IF chain. That'll be this tube down here. And just basically looking for one that has no high voltage on it or something crazy like that. It says 0. 0. Zero. Just check my connection here. Yep. Make sure my meter's working. Hey, where'd the ticking go? -10, so that could potentially be a grid. It's a 0. Hey, I haven't found anything with any voltage on it yet. Checking the meter again. Yeah. How about that guy? How about this one? Oh, there we are. And the ticking went away again. Here it came back a little faster, didn't it? Isn't that interesting? That's very interesting. What's that tell you? This capacitor looks, well, it's just dusty. These all look crappy, don't they? You know what? Okay, let's do some capacitor, across the capacitor testing. We'll just test across capacitors and see what kind of nonsense we come up with here. Not the most meaningful way to test things, but 0. Especially capacitors to ground. Did I say especially capacitors to ground? Especially capacitors that are grounded on one side. Back to this. One side's 8, other side's 80. This side's got 10. I think I did this one before already. 0. Funny sound. Wow, pretty hard to even see where the there's a 0 there. And one of these is hard down, shorted. This guy. Wouldn't expect anything on that one. And there's a few more up in here. Wow. There's 200 volts on that side. And my meter just timed. And this silly meter, eh? This meter times out no matter what you're doing. Well, that's interesting. I got 200 there. Okay, so we got 210 on this side. I can't really see where that capacitor is going. 2 almost 10 there. I think it's going here. There's 0 there. That's what you'd hope, because this other side's got 210 on it. Really hard to see where that, I can't see where that capacitor goes. Okay. So there's a question here about changing all these. Look at this one's got a crack right down through here, right up through there and gone. This one's cracked right through there. This one I think I saw it really has a crack running right through, yeah, right through the middle of it. So, I hate to say it, but I think I've got to change about 20 capacitors in here. You know, or I'm going to be chasing either general weakness all over the place and 2 or 3 specific serious problems. That combination is pretty hard to troubleshoot your way through. That's for sure. And if that's the case, the troubleshooting is going to lead to these capacitors anyway. So I think that's the story. It's another big capacitor job here. And I know it as I look at this that probably 6 out of 10 capacitors are just fine and they don't matter at all because of their location in the circuit or whatever it might be. Bad is good enough, but I'm going to have to change them all anyway. Let's see, 1, 2, 3, 4, 5, 6, I'm counting the easy ones, 7, 8, 9, 10, 11, looks like 11 easy ones, and then difficult ones would be 1, 2, 3, 4, 5, 6, 7, there's probably a couple in there I didn't see yet, 7. So we're looking at about 20 capacitors, but a dozen of them are pretty easy. They'll take about 10 minutes each. So that's a couple hours there, and then the difficult ones will take 15 to 20 minutes each. And there was 5 to 10 of those. So that's another about 4 hours work here to change these capacitors. Good news is I got lots of capacitors now, so I'm not going to run out like I did on the other radio and have to start paralleling them and do other stuff. I think one of my big challenges is determining the values of these. I'm going to have to get the schematic for this radio because I don't dare try to. I think these are all these Autolite type capacitors rather. I'm not sure they have the value written on them. Even these ones I'm not so sure I can determine the value. Well, I suppose I can. I'm just not that experienced at doing it. Believe it or not. Okay. That's what we're going to do. First I got to get some information here.